hand it over to Robert Seacord, who, I don't even know what your position is, Principal Security Consultant?
Technical Director.
Technical Director at NCC Group.
I
does a lot of work.
technology.
Technology, yeah, secure coding stuff. Used to be at the CERT, and now he's at NCC and doing great things. So,
Thanks.
Yep.
So yeah, I'm Technical Director at NCC Group. I do some consulting, I do some research. There's actually a paper on our website that goes along with this. So if you want the 20-page version of this, you can download it and absorb it like that. I probably won't have enough time tonight to do as much details as in the actual paper. And prior to that, I was at CERT. We did some work on secure coding standards with Java. So the material from this is sort of taken from the CERT Oracle secure coding standard for Java. I've been going through that, trying to update that material. It actually sort of needs some TLC. I've been going through with Pearson and doing a video series of Java live lessons, trying to update some of this material. I'm stealthily thinking about writing a book on secure coding in Java. And so like this 20-page paper I put up on the site, I might write a bunch of those, and then if there's enough of them, I might try to stitch them together and see if I can trick a publisher into turning it into a book. So Java Serialization was introduced in JDK 1.1, which means it's more or less there from the beginning. It's the first transformation of a graph of Java objects into a stream of bytes for storage and/or transmission. And these bytes, of course, can be later, the object can be later be recovered from the graph bytes. The serialized form has to identify and verify the class corresponding to the saved object, and then restore the constants or the contents into a new instance. There's a tiny little picture of what that process looks like. So objects to be saved can either support the serializable or the externalizable interface. I haven't delved into externalizable quite as much. The sense I got from the limited investigation I've done is that it's just as bad, but most of the research doesn't really delve into it. Externalizable is different in that you determine the actual storage format, so that's really the only difference. For serializable objects, a stream has to include sufficient data to restore a compatible version of the class. Again, for externalizable, the class is only responsible for the external format of its contents. The programmer has to do the rest. So serializable classes can save and restore the fields of each class of an object, and they're actually, so there's a misconception, right? So the misconception is, well, we wrote this program and we use serialization to store some sort of database, and now we need to add things or change things, and we're stuck because we've saved it into this serialized form. That's actually incorrect. Serialization was designed to be evolvable. There are a bunch of concepts built into it that lets you sort of grow and evolve, and that's of course one of the problems with vulnerabilities and deserialization is that it isn't extremely rigid because it was designed to be evolvable. So serializable class can declare which of its fields are saved or restored, and write and read optional values and objects. So default serializable fields of class are defined to be non-transient and non-static. So static fields aren't serialized because there's no need to do that. And if you mark them, as a programmer, you can mark fields transient to prevent them from being serialized. And you want to mark fields as transient if basically, they'll have no meaning when you serialize. So if it's something, what the current time is, or something about the current system on which that object is being reconstituted, then it makes no sense to store and transmit that. You're just going to have to recalculate that when the object is deserialized. Okay, so let's say we want to just take today's date and serialize it to a file. Okay, so you can create a new file output stream and then wrap it into an object output stream. So the The file output stream is needed to receive the bytes, and then the object output stream is created to write to the file output stream. And the objects are actually written by the write object method. And so here we're going to, I've got a laser depth right here. So we're gonna write the string today, and then we're gonna write the date, and then we're gonna flush out the stream to the output. So this is all it takes. And the interesting thing about so this was one of my discoveries going through the process of this is actually part of a secure coding in Java course. So I actually did a full day on this. And now one of the things I'm thinking about is, can I really sell this, because it's only of interest to people who are doing Java Serialization. So I might have picked a little bit too niche of a topic there. But what I learned is a lot of people start looking through source code to look for read object calls, and that's exploitable. No, this is exploitable. Okay, so the big issue with Java Serialization is that you can do everything absolutely correctly, which this is absolutely correct, and this is totally exploitable by remote command execution, denom service, the whole works. Okay, so you can write it perfectly, and it's still vulnerable. So this is a big issue with serialization that's sometimes not apparent to people who think you have to make a read object call. So the write object method serializes the object and traverses its references to other objects in the graph to recursively create a complete serialized representation graph. So if you have an object A and it has a couple of B's in it, and the B's have C's in it, you have to serialize all that data in order to be able to reconstitute the entire object when you deserialize. Primitive types are also serialized, so you don't have to mark those explicitly as serializable. So when we go to deserialize, we basically just inverse the steps, and you'll see that these things are just sort of reversed in process. So we'll create an input stream, and we'll wrap an object input stream around that, and then we can go ahead and call a read object for the string, and then read object for the date. So the input stream is needed as the source stream, and the object input stream will deserialize the data from the input stream. Okay. So the read object method deserializes the next object in the stream and traverses its references to other objects, and then cursively deserializes the complete graph of objects. Okay. And again, object input stream can be extended to use custom information in the stream about the classes or to replace objects that have been deserialized. So you actually don't have to keep the same object. There's an ability to sort of replace it with a different object. And that'll let you do things like use proxies to represent objects. So the object output stream implements object serialization. It maintains the state of the stream, including the set of objects already serialized. So the methods traverse objects we serialize to save the specified objects and objects to which they refer. And the write object method is used to serialize an object to the stream. Okay, so only the data is serialized, the code is not serialized. So the code has to be present on the platform which is doing the deserialization, and that's part of the requirement, right? So, so what you typically hear is that the class has to be on the class path. It's actually a little bit more complex. It's basically it's going to follow the mechanism for loading classes that the JVM follows, which involves which class loaders were involved, and a more complex topic. But there's probably and no one talks about this at all, but it's I would think if I were deploying a Java application and I was concerned about security, probably the first question I would ask myself is where are these classes coming from? I mean, and making sure that those things are all locked down, because probably most people don't really know those set of directories in which classes will be discovered and in what order. Because they're all good sort of targets for planting Trojans, I suppose. Okay, so the single argument object output stream constructor creates an object output stream that serializes objects, and the constructor first calls write stream header, and it prints out some magic information. So you get a magic value ASED, and you get the stream version. And so I think the current version is 5. So these could be 1 through 5. So that's going to be read and verified by the corresponding call to read stream header in the single argument object input stream constructor when we go to deserialize this. So if a security manager is installed, the constructor will check for the enabled subclass implementation when invoked directly or indirectly by the constructor of a subclass, which overrides put fields or write unshared methods. And this idea of running a security manager with deserialization is a good mitigation. Whether or not it's 100% effective at preventing vulnerabilities is unclear, but it does mitigate for certain, right? I mean, so if you have if the remote command execution that's attacking you is trying to load a file, and you're running with a security manager that prevents loading of files, then that class of attacks would then be ineffective. Whether or not you can disable the security manager for a deserialization attack, I have to investigate more. I know Svoboda talks about that on a slide, and I was actually at Java 1 a few years ago, we presented that. I think that exploit required multiple vulnerabilities, not just a single deserialization. So developers can implement methods to customize how objects are serialized and deserialized, and this comes in handy when trying to be able to evolve some of these classes. So write replace provides a replacement object to serialize, so that allows for the use of proxies. Write object gives full control over writing the stream, and for deserialization, read object gets full control over reading the stream, and read resolve will replace a deserialized object with another one. So you can override both of these methods and change how you read an object and then replace it with a different one, and that's sort of how the proxy pattern works. There's also a validating object that gets called once optionally at the end of the process. That's another potential area for overwriting. And the final area is not even on this slide, is the finalize method, which is actually particularly troublesome because it's called by the garbage collector thread, which runs in a separate security context. And so that could actually be quite problematic. So the write replace method is executed first. If present, the write object method will operate on the replaced object, which only makes sense, right? You don't want to start working on an object and then not use it and replace it with a different object. When you deserialize, you read the object first, and then you potentially replace it with a different object, and then finally there's a one-time validation step at the end. So the validation method is executed only on the replacement object and not on the originally deserialized object, which is silently discarded. You guys don't ask a lot of questions. This one dude nods a bit. I feel good about him nodding because maybe he's just nodding off, but at least it seems like he's following. So this is a helpful slide. It's always nice to have a graphic. So the application here, initially gets the bytes from a file, from a stream, what have you, initializes or constructs an object input stream, then calls read object. That transfers control to the object input stream, which will resolve the stream classes using resolve class and then deserialize the graph of objects. So this then control link goes back to the serializable class, which restores the object member fields by calling read object or read object no data. Read object no data is another one that I'm trying to get more of a handle on. That's something that was added in like Java 1.4 to address an early vulnerability. I think it has something to do with when the class can't be found. When you try to serialize, and that was used in exploits. Sorry I'm a little weak on that, but this is, this is a cut down from a full day tutorial, and that full day tutorial is currently still insufficient to do this stuff securely. I'm not quite sure what the end of this is. We'll kind of show you, or we'll get to talking about how you can do this a little bit more securely. But the advice, and maybe you can see this coming already, is generally speaking, you seriously want to avoid deserializing data from untrusted sources. And I put that in the paper, and I got a lot of internal grief from people at Seacord who said, well, that seems to imply that you can deserialize data from trusted sources. And I said, well, yeah. If you're writing both sides of this, it's okay to deserialize, right? But then this guy went further, I think, into sort of kind of crazy land, where we're getting this on tape, right? Because all my coworkers hear this. Where his concern was, well, people might think they've got a trusted connection when they don't. But to me, that's a whole different topic because that's all domain specific. Okay. So at the end, we cast the deserialized object to the expected type, and then use the deserialized object, and then eventually, again, the finalize method is called from the garbage collector. And this can be dangerous. The cast here is relevant in that, I might be getting ahead of myself, but I guess I'm about to say this. So when you deserialize, when you cast to a given object, that might be the first time you realize what type of object you're dealing with, right? So that cast might fail because it might not be the object expected. It might be basically an exploit object, right? And so you'll get a cast exception there. But the whole point of this is it's too damn late, right? Because what's happened, this method's run, this method's run, this method's run, this method's run, right? Bunch of shit's run. And so before this code ever returns to you from this call to read object, the exploit's finished. Okay, the attacker's gone off. We basically executed a collection of gadgets, right? And so the concept of gadgets is that it's code that exists in the target, on the target platform, right? So return-oriented programming, that's a series of little snippets of assembly. But here, it's basically code somewhere in a read object method or a read resolve method or a validate object method that does something interesting in situations where the attacker supplies the data, right? And there's some number of identified gadgets, but the real number is basically, I'm just going to say unlimited. There's an unlimited supply of gadgets. I'm just going to do a time check because I've got this sense I'm doing horribly. 7:25. So, naive use of object serialization, which might mean any use of object serialization, may allow a malicious party with access to serialization byte stream to read private data, right? So there's no absolutely zero attempt to make this information private, right? So if you serialize someone's credit card information, you put it on a disk, on a file, and someone sees that file, they have that person's information. No attempt at privacy with serialization. Create objects with a legal and dangerous state. So you get a hold of the serialized data, right? There's a specification. You know exactly what each bit is and what it does. So you can alter those bits and create whatever type of object you want, even if that sort of object breaks invariance and is infeasible that object could ever exist in in a real application, but you can create it in the serialized data and then deserialize that impossible object into memory.
Now, is that something that the security manager would normally catch, or
No, not at all. Not at all. Yeah. So, I didn't say this at the beginning of this, but, serialization is just an inherently insecure technique, right? Because at its core, it's basically, let me take code from somewhere and run it, right? That's what we're doing, right? And so locking this stuff down is really difficult, So there might be, somewhere there might be a subset of this that's secure where you can sort of do kind of plain data, but it's, and I'll talk about mitigations, and the best mitigations I'm aware of are inadequate. I mean, so I can maybe argue that I can prevent against remote command execution in limited cases, but there are denial of service attacks to which I'm not aware of any known defects. And a lot of people tell me that, so what? It's an unsolvable problem in general, but I'm not smart enough to make that assertion. So you can obviously obtain references to private fields of deserialized objects, and this is a good graph. This is, if you want one graph to sort of summarize this topic, this is how smart you need to be to write serialization code. This is Mark Sherman smart. Hi, Mark. And this is how smart you need to be to get it right. Okay, and the gap from here to here is tremendous. At least I didn't say Gary or Grossmark, because he's got a lot of money now. He could probably come after me. Hi, Gary. So default serialization of an object writes the values of all object fields to the serialization stream. That includes private, package private, protected, public. And once you serialize that information is available for everyone to see. So frequently, you want to give a lot of thought to private fields, right? So these be transient in terms of not writing that information out. But of course, that means that you need to reconstitute it, right? So if you have someone's credit card information, how do you transmit it? That's a tough problem, right? Because if you don't transmit it, they don't know it. They can't reconstitute it, so it does really have to be transmitted at some point. So obviously malicious code can easily read the results, and you don't need code, you can just do it with the editor. So there are a variety of security risks with deserialization. So the consequences, so there's this one CWE that sort of covers the range. The consequences vary widely depending on which objects are deserialized and how they're used. But basically, all three aspects of CIA can be compromised with deserialization attacks. So again, during deserialization, objects are created, initialized using data from incoming stream. These can easily be corrupted or tampered with prior to deserialization, particularly if these are used, say, as cookies and sitting on a file system where someone can just edit them. So during deserialization, attackers can also forge spurious references to objects in the stream by inserting extra handle references into serialization byte stream. That's a whole class of attacks that I'm not going to talk about too much in this 1 hour. And so it's unsafe for developers to assume that references to private objects are unique. So deserializing untrusted data can cause Java to create objects of arbitrary attacker supplied classes. So here's the loading process. So JVM walks the stack and uses the first non-boot class loader it finds to identify the classes. RMI, which I don't talk about, RMI uses serialization underneath of it. RMI can also use a remote code base. RMI, I need to put together a half-day lecture on because it's really problematic from a security perspective, even more problematic maybe than deserialization. So again, some classes have triggers that will execute additional code. So if these classes are poorly designed, they could invoke arbitrary methods with attacker-supplied arguments. So again, just going back to the same chart, each of these calls here is an opportunity. Each of these calls here is an opportunity for malevolent action. And again, the attacker does not supply the code. Okay, these are going to be gadgets. These are going to be code that exists in the space. But a lot of times, this code is kind of poorly designed. And what the attacker does control here is all the data. Okay, all the fields, all the data that's used to load up the class. So if you have an action that used to be safe because you had invariants which controlled what sort of data was operated on, the attacker can violate those invariants and trick your code into operating on data that was not expected. So here's a simple, unrealistic example, but it's a really good place to start because it sort of lets you understand how this stuff works. So here, we've got a private field called plan, right? So you as a programmer might think, well, there is no way someone can modify the contents of this because it's a private field. Okay, so we're going to do a read object, and then in our over the read object, we're going to call exec.command. Okay, so this is a non-realistic example. Hopefully, you don't have this in your systems. Hopefully, no one's written this. But you can see very easily now, right? When someone deserializes this, if they get a hold of this object, they can insert any command they want into the serialized form of the object. And when you call read object to read it, even before you know what object it is, right? It can, it will load this and then call read object. Okay. So again, to be clear about that, let's say you have a bicycle object, right? And you serialize that, and then you read the bicycle object back. Okay. What happens is you're not reading a serial bicycle object back. You're reading whatever object back. Any object in your entire, anything in your entire class search path. Right? Any class that the loader can find, it can be loading that object, right? And so what the attacker's going to do is, in all that code, they're going to find something like this for you to load, right? And supply the data that's going to cause the attack. So the class it runs, the code it runs, has nothing to do with the object that you think you're deserializing. So you don't have to screw up writing your deserialization things to be vulnerable to these attacks. You just have to serialize something. So these are, my sense of this is much worse than people think. I mean, this is just, some people understand how bad this is, but this is very bad. I sound like Trump there, but I'm so sad. Okay, so, I think I've killed that. So again, developers put too much trust in Java object deserialization, even deserializing objects pre-authentication. Deserialized objects, again, typically cast to expected type. So the Java's type system will ensure valid object trees, but again, before you get there, all this bad code is run. Okay, and part of what the just like sort of ROP attacks, an attacker will actually create chains of gadgets. So they'll find a bunch of objects, each of which perform some of the functionality they want, and they'll chain these things together in order to create the desired effect. So one of the things that's most famous is the Apache Commons Collection Invoke Transformer class, because it lets you do some really cool things, like, execute methods, right? And so this is, again, used in a lot of places. I now have it, actually I might be in because I teach about this. Sometimes I wonder about that, like all the crap I put on my computer so I can demonstrate vulnerabilities. Okay, and if you go to the Apache Commons site, this is what they tell you. They say, this is not our fault, right? Because they have a tool, but what's happening is that people are misusing the tool. And they're mostly right. Okay, I'll show you this later, but they fix this problem. At least the existing exploit no longer works. But it doesn't matter. There's an unlimited supply of these gadgets elsewhere, right? So these guys took a lot of heat for something which wasn't entirely their fault. They could have done better now they have. So invoke transforms objects in collection by invoking a method using reflection. Attackers could use that functionality to invoke any method, including call runtime exec, and they do that by creating a method sequence, which is typically referred to as a gadget chain, and each object in that is a gadget. And so the invoke transform is usually the final gadget in that chain. There's also this concept of golden chains, which is mostly kind of wrap stuff, but so these are basically chains that only use gadgets from the JRE, right? So you can always attack the system you're attacking. You don't have to depend on them having these third-party libraries. And there are these golden chains that are available. The problem with security, right, I'll give you this demo, is that as soon as these things are reported, they get fixed. So I can do a demo on an old version of the JVM, which is sort of disingenuous because I have to go back to the old version to demonstrate the problem. Or I can go find a new one. But if I find a new one, I'm going to feel obligated to report it, and I'm going to consequently invalidate my slides. So when I demo this, it's actually a kind of a failed attack because this problem had been fixed with invoke transformer. But I will show some successful attacks. So again, as I pointed out, this particular problem has been fixed.
So how do you decide what gadgets uses are
As an attacker.
just randomly pick gadgets? How do you decide what the chain to get?
Yeah, so here's the easy way, okay? I had that first slide with the Joker, is it why so serial? There's a tool called why so serial. And you download that tool and you tell it what your payload is, what command you want to run, and you press the button and it generates a gadget for you. So you can just use that. The other thing you can do, if you're a researcher, right, is you can start with that and look at their chains, and then you can think, oh, this is interesting. What other chains can I put together to perform other fun things, right? So go get the open source JDK code, look for interesting stuff in these methods. I guess you just start looking for these read object, these overridable methods, and look for interesting things that are being done. Yeah.
Yeah,
Sorry.
so I get that if you have an object that has like execute this code or this command,
Yep.
you can overwrite that command and then it runs that and deserializes it.
Right.
But can you go into a little bit more detail about the gadgets themselves, like why you would need, what do they do? Like I understand block gadgets from like an x86.
Yeah. Well, the gadgets do whatever they do whatever they do, right? So it's just code that runs with data supplied by the attacker, right? So let's say the code opens a file, okay? So now what can happen is you supply as an attacker the file you want to be open, and when that code runs, it's just going to open that file, right? So you get whatever sort of functionality you want, but the surprising way to the object was thought that was a private field, and they had constrained very carefully what values could be in that file name that you're about to open, right? So it can do whatever. It's sort of like insecure file operations too, right? If you let the run with elevated privileges, and this is again why it is a valid defense to run this with a security manager, right? Because at least you want the security policy during deserialization to be the same as during serialization, right? You don't want to, the best way to start with deserialization, the same way you do all security policies, right? You turn off everything, and then you enable what you need, and then you look at what you're enabling, and you decide, can I live with this enabled? How much risk is that exposing? And the answer is probably too much, if you need to enable any at all. Okay? You okay? So there's been a variety of denial of service attacks. There's one by this guy, and these guys are also clever. So he has a hash set with cycles where the deserializing will recurse indefinitely, consuming CPU. I have a demo of that, but I'm not going to do it because I didn't realize I'd left that little demo diagram in there to just now. But I only left time. I could do it, but I only left time for one. So this is an example of sort of vulnerable systems and vulnerable exploits, right? So basically, the story here is that there are a lot of vulnerable things. Java Serialization underlies all these technologies, right? So if you're using any of these technologies, you could be susceptible to these deserialization attacks, you know. And the way people fix these is almost entirely inadequate, right? So all these things are always solved by basically blacklisting the particular object that was used in the attack, you know, usually the transformer, right? So it's only protecting against that, not against the undiscovered, underreported problem. Yeah.
So you're mentioning different protocols and products that have issues because of this, but I guess my question is, where are some of the most common injection points or control points that people find in these products? Are they a specific kind of interaction with, say, like if it's a Java Spring application, where is there certain usage of it that tends to be able to be controllable by an attacker?
Yeah. So I'm not an expert in all these technology stacks, but I'll just throw out like a simple example, right? But people will create serialized cookies, right? And so it's very easy for one of your users, say I'm PNC Bank customer, right? And they save my account information on a cookie, so I'll edit that cookie and I'll replace that account information with someone account information who does much better than I do, right? And then I'll make some withdrawals. I mean, something like that. That's just, I would guess that would be common because it's just so damn easy, right? So that's really kind of maybe the low-hanging fruit of exploits. You don't really have to write a code to do that. That wasn't a great answer, but probably the best I can do. Okay, so to prevent these attacks, you really have to not deserialize objects with arbitrary classes. And based on what I've told you so far, that's impossible, right? Because you deserialize them before you know what you're deserializing. There's always going to be vulnerable classes that can be leveraged for the attack, and those can be used for denial of service, remote code execution, and everything in between. So an attacker could serialize an instance of an unexpected class, send it to a service, deserialize a malicious object, probably cast it to the class it's expecting, cause an exception to be thrown, but that again is too late to prevent the attack. So the JDK deserialization invokes the following methods if implemented. The read object is used by developers and standard serialization cannot be used. And elsewhere, right, when you're trying to explain to someone how to write good deserialization code, you will tell them to write a customized read object method in order to write good code. So again, this is not uncommon. This is actually best practice, and that's sort of surprising to people as well when you're writing deserialization code. Read resolve, again, typically use the deserialized singleton objects using a proxy. Read external for externalizable objects. We didn't talk a lot about externalizable, but again, those are equally vulnerable. And finalize is kind of the forgotten thing, which might again be the most dangerous. I want to skip this one. Maybe I'll show it. So here's file upload, and this is a good example where it's just going to take a file that's data, right? So this data can be supplied by the attacker, and it's going to delete it, right? And so you can use this as a gadget, just start deleting files on the system you're attacking. So again, the code does whatever the code does, but it doesn't by request of the attacker using attacker supplied data, which is, just infinite amount of fun right there. Keep yourself entertained for months doing that stuff. Okay, so here's a bicycle class written by Pierre Ernst at IBM, it's just a reasonable implementation of a serializable class that implements a bicycle object. This is what it looks like if you look at the ASCII, and you can look over here and you can see stuff. Right? So you know what class is here, and you've got information about the object. So there has to be adequate data here, basically, to tell the deserialization function what type of object is it that you're reconstituting and what is all the data that's going to be in that reconstituted object. So when you look at this, you've got the magic numbers here in front. The reason I keep putting up these magic numbers, I forgot earlier, I would have said it then. Right? This is for people who do firewalls and stuff like that. They want to keep an eye out for deserialization traffic. But my key point here is that you can tell what sort of objects you're going to deserialize because that data is here, right? But no one's been using this information until recently. Okay, so this is transitioning into some of the defenses against this. The two common approaches are whitelisting trusted classes, and I think this is a valid solution, right? Now, when I talk to Oracle people, they'll say, no, this is bullshit because it prevents the capabilities of deserialization, right? And the response is, your capabilities are killing us. So I think it's a valid solution. But basically what this means is just basically say, I've got 3 or 4 different objects that I potentially are deserializing. That's all I want to serialize. And if the class evolves, if something changes, tough shit. Your code is broken. You're going to have to rewrite the code and do something to modify existing serialization files. The alternative is just don't use it. Right? So again, you specify these in the whitelist. This is accomplished by overriding the resolve class of the Java object input stream method. So that's done in something called a look-ahead object input stream, or LAOIS. I kind of figured some way to get my boss to send me the LAOIS to work on this. Too bad I'm not working for Mark anymore. I might have been convince him because two things were related somehow. So there are a variety of off-the-shelf solutions. So this the irony is because Apache Commons has a solution. So basically you install Apache Commons, so you have a solution to the problem created by installing Apache Commons. That's kind of ironic, right? So my favorite is JEPS 290. So this is basically JEPS's Java Enhancement Process. So this is a feature added by Oracle. It's fully implemented in Java 9, and they took some of the quick fix portions of it and backported it to 6, 7, and 8. So you can use this in new releases of 6, 7, and 8 as well as 9 portions of it. I feel like I should have had the demo by now, but I guess I'm going to have the demo in the end. How much time? What time is it?
That's 10-2.
10-2. That sucks.
Get some time after.
Okay, what's that?
Get some time after the hour. And if
Should
people start
not-
revolting and leaving, we can
Probably shouldn't have told me that, but okay. let me jam through this. So Java 9 again adds some serialization filtering, some whitelisting and blacklisting. So this allows you to narrow set up the serializable classes to appropriate set of classes like just the bicycle. You can also filter for graph size and complexity in order to limit sort of these unbounded graph sizes or just amount of data that an attacker might launch you to try to prevent DOS attacks. And not all the solutions I listed work for DOS attacks. They all address at least RCE. It also defines a global configurable solution and filter, and that's a part that's backported to 6, 7, and 8. Right? So if you want a quick fix, you can set a system-wide filter, say I don't want any of these classes, or I only want to allow these classes, and that will, that will make you feel better, especially blacklisting stuff. Yeah.
So for the second bullet, the filtering the graph size and complexity, is there an easy method for determining what graph size and complexity is normal with an application and set that as your baseline?
Well, yeah, so here's what I would do. Well, yeah, I mean, so here's what I would do, right? So there are some of these tools which have collect metrics, okay? Or you could just put a print statement into your deserialization code, right? And so what I would do, right, is basically instrument your deserialization code, right? Run it on your data sets, right? And then find the maxes, and then plug in all the max values. And that will work until things go up. So you could make it also, you can make it user configurable. So you can put those maxes in a secure configuration file from which they're read, so if they go up, your customer can adjust them at, after deployment. So I think that's the best solution. And the question always is, how big can you make those numbers before you're in trouble? And unfortunately, there are deserialization attacks, for which JDK 290 is ineffective, right? And I asked the author of JDK 290, if they could defend against this, and he said, we can't reply to that, which is Oracle speak for fucking no, right? I guess. So, yeah.
So this might go along with whitelisting if you can control it at this level. But is there any thought, and I can be completely off the reservation here, but is there any thought to possibly like signatures or integrity checks? If you have first-party systems that you control both sides of the serialization, you can confirm that it's the same coming from A to B. Is that?
Yeah. Well, so I'll say something and I'll get your reaction. So this could be a learning experience for me too, right? You can sign and seal objects, right? And so one solution here is you take your object graph and you put it in an object and you sign and seal that object and you transmit that, right? And I sort of think, okay, that solves the problem. And what I'm wondering is, why am I wrong? Is that too expensive? Why aren't people using that as a solution, right? The other solution is that you have a secure, authenticated interface with a trusted, user. But that gets into the thing my associate's concerned about, that people misplace trust in those situations. Yeah.
In that scenario, do you run into problems, say if you have like a larger end-tier environment where you're communicating between a cluster of things? Do you have to, sort of like when you're using Max and other encryption for view state objects and that sort of thing, where if serial data is generated in one part of an application but read in another part, or in another system altogether?
I would say no. I mean, he's saying yes, but I mean, so first of all, it's Java, right? So it's write once, write anywhere mostly. I mean, so you're transmitting data. It's a well-defined standard format, part of the problem, right? So that part's not an issue. And the part about, digital signatures and all that, code signing, I mean, that's also standardized. So I would think every system would be able to do that. I don't think, there's a system that's going to have little endian instead of big endian or something like that. Okay, any other questions? You sensed that I wasn't going to finish on time. You said, let's totally stop it. Get through these last few slides. I didn't mean that. I like the questions. I feel like I was being to you when I asked questions. Yeah. Okay, the core mechanism is a filter interface implemented by serialization clients and set on the object input stream. So the interface is called during deserialization to validate the class that is being deserialized. So basically they look ahead, right, as the name suggests, into that stream of data, and it sees what are all the classes that we're deserializing. Are any of these on the blacklist, or are some of these not on the whitelist? And again, you can also set the size of arrays being created, because a very easy DOS attack is, they're creating an array of some size where the size is specified in class, right? So let me put 8 max, boom, DOS attack. How easy is that? So the filter will either accept, reject, or leave the status undecided, meaning it's waiting for another filter to make the decision. So Java 9 has all the filters. It has the process-wide filter. It has custom filters that you can write and built-in filters. 6, 7, and 8 only have the process-wide filters. So a process-wide filter is configured via system property or configuration file. So that will be in one of these locations. And you can include whitelist, blacklist, but also limit patterns. So you can set a max depth, a max number of internal references, a maximum number of bytes in the input stream, and maximum array sizes. So this is used to combat DOS attacks, but it's not 100% successful. There are attacks which can succeed against this. For the filters, here's an example setting a property, a process-wide filter. So here, I say, hey, I want to serialize a bicycle. I'm only going to have one object. I only have one reference. It's 78 bytes long, and it's going to have an array with 10 elements. Okay. And the way I got this was, I wrote the code, I deserialized it, I printed out all the data, and I said, this is my object. Now, if someone created an object where the name of the bicycle was a little bit longer, right, then this would block it, right? So you have to kind of figure out what is the largest object you're going to have reasonably support here. So custom filters can be written by implementing the object input filter interface. This is only available in Java 9, and overriding the check input method. It has additional methods to set and get the current filter, and if there is no filter set, then it uses the global filter that you set in the configuration file. I'm going to skip serial killer. We'll skip this. This is the one from Apache Commons, which is okay. So here's the demo. Yay, demo. Okay, so we see code. This is actually the right code. So it's lucky. Can we make this a bit bigger? Everyone in the back can read the code? Yeah, good. Okay, so I'm going to just start debugging this. And typically, I've left a breakpoint in a good location. This is what happens when you're an old guy. I have a note on my front door that says, go back, put on pants, before I walk out the front door. That's saves a lot of money on lawsuits, really. So here, we're going to serialize a bicycle object, and then, I guess that's what we're going to do. So we serialize a bicycle object, and you guys have seen the bicycle object already. I'm not going to show it to you again. And then we're going to serialize a file object. Okay, and the point of the file object is it's not a bicycle, not a bicycle object. And here, we're going to deserialize the bicycle object and print it out. That succeeds, okay? That's the valid use case. We want to serialize and deserialize a bicycle. But now we're going to deserialize the serialized file, and that's going to work as well, okay? So I did something here. Maybe some of you noticed the difference. So here, I put the object, I cast it to bicycle, right? And here, I cast it to object. Okay, so the fact that I cast it to object allows this code to fail without giving a cast exception, right? Because this object is a file and not a bicycle. So code that looks like this is especially bad, but even if I had put bicycle here, again, it doesn't matter. All the exploit stuff is already run. It's just eventually your code will crash, as opposed to this example where it will continue to run. Okay, so now I'm going to deserialize the RCE payload. Let me show you the RCE payload. Okay, so this is something I took off of, WISO serial. We create a constant transformer class, create a new object foo, get some arguments, call a chain transformer, create a priority queue, put the transformer into the priority queue, we set some fields, and then we serialize it. So we're kind of chaining together this series of objects. So normally, this will deliver a payload. Here, the payload is going to run the calc exe program. And so you can put your payload there, whatever it is. So when I execute this, I get an exception. Okay. So the problem is, if you go to the Apache page, they'll tell you that they modified their class to make it not serializable. Okay. So this attack fails on recent versions of Apache Commons, right? It will still succeed for older versions of it. Now again, I didn't want to fake anything here. I didn't want to put an old version of this to get the demo to work. Okay, the fact that this field failed, okay, doesn't matter in the least. Okay, there are a gazillion other gadgets out there, all of which will succeed. The problem is if I find one, I have to report it, and then it will fail again. So it's sort of a pointless cycle for me to find them. But again, don't worry about it. If you do this, you're vulnerable. And now I'm going to do this this DOS payload. If I go up here and show you the DOS payload, the DOS payload is the one from that guy I mentioned earlier. I think he's from Denmark or someplace where their names are hard to pronounce. And he's just got this hash set which sort of creates references to other hash sets within it. And this was crafted basically to not fail. Okay, that was the key to this, right? It's easy to make this blow up. What this guy managed to do was he managed to come up with an object which will run forever without failing. So if we go ahead and single step here, you'll see that we're processing, right? I can't single step again. I'm waiting for it to come back. Okay, this is a long wait for train income. This is gone. So that particular exploit can be blocked. That DOS attack can be blocked by JET 290 that I was showing you, but there are other deserialization attacks which cannot be blocked by it. So it's basically not 100% effective. I think I had a couple other slides, 3-4 slides, and then I'll let you go. So, or go get meters. So I've said that a lot. JET 290 does address both RCE and DOS. Maybe I'm selling it too much because it doesn't work against all DOSes. So, if you use it, you're still vulnerable to that style of attack. So you're acknowledging that risk that your system can be subject to DOS attack. There are a bunch of alternatives. Okay. So here's the scoop on alternatives. To the degree that people have investigated these alternatives, they are less secure than Java Serialization. Right? To the degree they haven't examined them, they look great. Okay, but it's only because people haven't looked yet. Okay, chances are really good that all these things are much worse. because Java's been around since serialization has been around since Java 1.1. So it's become more secure over 30 years or whatever it's been. So for those of you who go to Black Hat, there's supposed to be a talk on RCEs for Jackson and JSON. So if you thought JSON made you secure, go sit in that talk and have everybody find out. Okay, so again, the scary thing here is you can do everything right and you've got a vulnerability. The primary mitigation is just don't deserialize untrusted data. The Oracle coding standard has a rule like that, and all those other solutions for doing this kind of thing might turn out to be actually worse. And that's all I have. Anyone have any? Anyone have any more questions?
So were there wild exploits for the Apache Commons thing?
Yeah, I think so. I mean, it's in all sorts of web frameworks and WebSphere. You guys would know that more than I would.
Yeah, they probably do. I don't.
Yeah, I'm pretty sure this was actively being attacked because it's honestly it's just super easy. You know, I mean, there's a tool. I guess that's like a kitty script kind of tool, right? Just say here's the payload I want. Aim it at your target IP address. Yeah.
If you created your own web application, like you mentioned the bank, it was serialized and storing it.
Yep.
Would something like that by default just be vulnerable where it would typically exceed?
Yeah. Well, you know, yeah, it's vulnerable for probably every reason, right? So the first vulnerability is the one I talked about, which is playing with the fields, modifying them in order to, you know, get into someone else's account and stuff like that, you know, absent other controls. But also probably, you know, I could write some code which would generate that RCE attack, right? I can store that in the serialization file corresponding to the cookie, and then when you contact the server, it will send that file over, and that will launch the RCE or the denial service or whatever it is. So I think that's just a very simple case where the whole range of exploits are on the table. Yeah, it's not hard. Okay, other questions? Yeah. So, yep, thanks for your time. I have a whole day on this. If you want to, you know, if you have to do this, you probably want to spend a whole day with me and then maybe some more time. But I also do like a 5-day secure coding in Java where we do numerics, and I have a whole day on exception handling that I sent to some more people who are code review, and they said, "Oh, thanks for sending this. We learned a lot," which is a little bit frightening, but it's pretty good. Everyone, like I do, when I'm not doing training or not writing papers, I do you know, code analysis for customers. And the reason I did a day on exception handling is every system I've ever looked at does it completely wrong. Okay, so sometimes there are 1 or 2 guys at a company who know how to do exception handling. So you will find examples in the code of it done correctly, but the other, you know, 100 people at the company don't know how to do it. And so every system I've ever seen has it completely wrong. So that's an area where we need to improve. Everyone does string handling in Java wrong too, by the way. Everyone thinks that char represents a character in Java, and it does not. Yep. No. Any other questions? Okay, thank you very much.